Chapter 7, Similar Polygons. Today we're going to cover Section 7.5, Theorems for Similar Triangles. Your class opener. Draw two similar triangles, name the properties of similar triangles, and 3, label the measures of the angles and the sides in the similar triangles. The section today, the objectives are, after studying this section, you'll be able to use the side angle side similarity theorem and the side 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 similarity theorem to prove triangles similar. Side angle side similarity theorem. If an angle of one triangle is congruent to an angle of another triangle and the sides including those angles are in proportion, then the triangles are similar. So if I look at the two triangles up here, I'm just going to pick a top angle. So if this angle is congruent in each triangle and the sides that make up that angle are in proportion, so I'm thinking the triangle on the left, if these two sides are in proportion to these two sides, and I'll give you some examples. Let's say this is A and B, and this one is X and Y. So if A over B equals X over Y, then the triangle is going to be similar because the angles are congruent and the sides will be proportional to one another. Side 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 similarity theorem says if the sides of two triangles are in proportion, then the triangles are similar. So if the triangle on the left, if it was A, B, C, and the other one was X, Y, and Z, if all the sides were proportional to one another, then I would have similar triangles. And if I was dealing with all three sides, to me the easiest way would be to set up one proportion that dealt with all of the sides. So if I had A, B, C on the top and it was proportional to X, Y, and Z on the bottom. So if all of these ratios were the same, then the triangles would be similar to one another. Okay. Can the two triangles shown be proved similar? If so, state the similarity and tell which similarity postulate or theorem you would use. So in my mind I'm thinking I'm going to try angle-angle similarity, the side-angle-side similarity, or side-side-side similarity. And I typically look at it and say if I have two angles, I'm probably going for angle-angle. If they only give me one angle, I'm probably going to look for the sides that make it up. And if they don't give me any angles at all, I try side-side-side. So for number 1 here, they don't give me any angles whatsoever, so I'm going to try to see if side-side-side works. So I would try to think of making up a proportion, and I'm going to put all the values for the triangle on the left up on the top, which would be a 10, a 15, and an 18, and I tend to write them going from smallest to largest, and here's the reason I do that. If I write the 3 values from the triangle over here, all on the top from smallest to largest, then when I write the triangles from, or the sides from the other triangle, to match them up appropriately, I'm going to write them from smallest to largest. So now when I write the numbers on the bottom, I just make sure I go from smallest to largest. So the smallest is 16, then I get 24, and the largest is 32. Now I just come through here and reduce and see if they all reduce to the same thing. So 10 over 16, I can reduce by 2 and get 5/8. 15 over 24, I can reduce by 3 and get 5/8. And 18 over 32, let's see, I can reduce by 2 and get 9 over 16. And now I look at all of these ratios, 5/8, 5/8, 9/16, and they're not all the same. So this one ends up being not similar. Let's check number 2 here. Right away, I noticed that they give me these 2 angles, but they don't tell me any sides at all. But one thing that's sort of important is if these 2 corresponding angles are congruent, the lines are parallel, which means I'm going to get corresponding angles congruent over here. And even if I didn't know they were parallel, I could also use the fact that both triangles share angle A. So I technically know all 3 of the angles. So I am going to get 2 triangles congruent. One of the triangles is going to be triangle ADE. And it's going to be similar to triangle ABC. And the reason for that was angle-angle similarity. And let's look at number 3 here. I noticed right off the bat that the two triangles share angle C, and if I can get the sides being in proportion, everything should be okay. So I'm sort of looking at one of the triangles, I'm looking at 6 and 10, and the other triangle I'm looking at the longer lengths, which aren't in here, but I'm thinking the left side here is the 6 and 3 put together, which is 9. The right side is the 10 and 5, which is really 15. So depending on how you want to set up your proportion, you might put the values for the small triangle on the top, 6 and 10, and then the corresponding pieces below, which would be 9 and 15. But somebody else might write it differently and put the 6 over the 10, the one triangle by itself, and then pick the two sides in the larger triangle and pick the 9 over 15. And let's see what would happen. So if I pick the 6/9 and 10/15, I know 6/9 I can actually reduce by 3 and get 2/3. The 10/15 I can reduce by 5 and get 2/3, so everything looks like it would have worked. If you would have written the proportion the other way, the 6/10 you could have reduced by 2 and got 3/5, and 9/15 you could have reduced by 3 and you would have got 3/5. And either way, you're still getting the same ratios. So this one does look like it's going to work. So if I'm naming my triangles, I have sort of the small highlighted yellow triangle, which is triangle, I'm going to call it CDE. And it's going to be similar then to the larger blue triangle. And naming it in the appropriate way, if I name the small one CDE, the large one's going to be CAB. And the reason I knew that they were similar would be side angle side similarity. Number 6, given angle B is congruent to angle DEC, prove that DC over EC equals AC over BC. Well, I know that if I have a proof, I'm going to have my two columns of statements and reasons. I'm going to write down my given information first. Angle B is congruent to angle DEC. I know that's given. And I'm going to mark it. So angle B and DEC are congruent to one another. Trying to look at my proof statement. I know that if I can get triangles similar, that the sides would be proportional. And the proof statement is really that sides are proportional. So now I'm going to look over here and come up with how can I get that the two triangles are similar to one another. And I noticed that both triangles have angle C in them, and I could use angle-angle similarity. So my thought is using angle-angle similarity. So now I just need to state that angle C is congruent to itself. So angle C is congruent to angle C, and we know that's the reflexive property. Now I can state that my triangles are similar to each other. So I'm going to start with the large triangle, triangle ABC is similar to triangle, and now naming the other one appropriately, DEC. And I know my reason is just angle-angle similarity. And now if triangles are similar, these sides should be proportional. So I can write down that DC over EC equals AC over BC. And my reason is going to be, oops, that's right. So if triangles are similar, then sides are proportional. And your closure. I love math because